Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. Here you will find so many entrance exam question papers along with the PDF solution. So must visit it. You also must download our app. The link is available in the description box for a better preparation of the exams. Students, today we'll be solving TS EAMCET 13 May 2023 Shift 1 Physics paper. We already have uploaded your mathematics and the chemistry videos to explore that as well. So in this particular video, I'll be solving the physics part of the paper. Very best of luck. Here we go with the first question of physics. It says, gravitational forces operate among which of the following? All objects in the universe, some elementary particles only, charged particles only, or nucleons only. I think you know the answer. The gravitational forces operate among all the objects in the universe. All object having mass will be affected by the gravitational forces. We are affected by the gravitational forces exerted by one object which is having some mass to another, which is having some mass to another object always. So all the objects in the universe, they are attracting each other with some force. It has to be noted that photons are massless particles, quanta of light, yet recent discoveries of gravitational waves and lensing showed that the light photons is also affected by the gravitational forces. So the answer to the question, option A. Hope you understood. Next is 82 question. Velocities and accelerations in two systems of unit 1 and 2 are related by this and this relation respectively. Here, m and n are constants. Dimensionally, relations between distances s1 and s2 and times t1 and t2 in two systems are. In the question, you are given v2 is n upon m square into v1 and a2 is equal to a1 upon m respectively, right? So let's say the initial velocities are 0. Let's u1 and u2 are 0. So by the equation v is equal to u plus at, you have v1 is equal to u1 plus a1 t1. If u1 is 0, v1 is equal to a1 t1. Similarly, u2 is equal to 0. That gives you v2 is equal to a2 into v2. Dividing both of them, you have v1 upon v2 is equal to a1 t1 upon a2 into t2, or you have v1 upon n upon m square into v1 is equal to a1 t1 upon a1 upon n into m into t2. Okay. Yeah. So next, yes. And what I will be doing, this will be the cancellations. So this will ultimately be equal to m square upon n is equal to n into m into t1 upon t2. Or you have t2 is equal to n square upon m into t1. Now from the second equation of motion, from second equation of motion, you have S2 is equal to U2 T2 plus half A2 T2 square. This is equal to 0. So this S2 is equal to half A2 is A1 upon M into M into T2 square. T2 is equal to N square upon M square into T1 square, right? So this becomes equal to half into A1 upon N into M into N power 4 M square into T1 square. Or this is N cube upon N cube 1 by 2 A1 T1 square. And this is S1. So this is N cube upon M cube into S1, or this is equal to N upon M cube into S1, because this is equal to S1. That makes option, let's check, that is, here it is, option A is the right answer. Hope you understood that. Let's move to the next question. Question number A body starts from rest with uniform acceleration. If the velocity after the nth second, last second is v, then the displacement in the last 2 seconds is. Select the initial velocity u is equal to 0. Then the acceleration you are given is equal to a. Thus, I'm using v is equal to u plus at. I'll get a is because u is equal to 0. Then acceleration will be equal to, because at the nth second, I'm taking the time as n seconds. So a will be equal to v upon n. Now, for the displacement in the last 2 seconds, displacement in last 2 seconds, you have t is equal to 2, or you will have s is equal to vt minus half at square, or this is equal to v into 2 minus v upon 2n into 2 square, which is 2v n minus 1 upon n. So s is equal to 2v n minus 1 upon n. That is equal to option D. Hope you understood that. Let's move to the next question. For a stone projected from the ground with a velocity of 50 meters per second at an angle of 30 degree with the horizontal crosses a wall after 3 seconds. The horizontal distance beyond the wall that the stone strikes the ground is. You have to take the value of g as 10 meters per second. So in the question, you are given u, initial velocity is equal to 50 meters per second, and the angle of projection, let's say theta, as 30 degree. The time of flight, t is given by 2u sine theta upon g. Sorry. So 2 into 50 into sine 30, g's value is 10. This will be equal to 100 into 1 by 2 upon 10, or this will be equal to 5 seconds. Now the range is u square sine 2 theta upon g. So this is 50 square sine 60 degree upon g. This will give you, on solving, 216.5 meters. Now we have the time as 3 seconds. At that, t upon capital T is equal to x upon r, right? So let's fill. You have time as 3 and capital T is 5. Just solved. That's equal to 5 seconds. Is equal to x upon the range is 216.5. That will give you x is equal to 3 into 216.5 divided by 5. On solving, you will have this as 129.9 meters. The distance beyond the wall where the stone will hit is distance beyond the wall where the stone will hit will be given by range minus x, that is 216 minus 129.9, which is equal to 86.6 meters. So this is the answer to the question. Option C is the correct answer. Hope you understood that. Let's move to the next question then. Question number 85, a body of weight 50 newtons is placed on a horizontal surface as shown in the figure, like this. The minimum force required to move the body is this much newtons. Frictional force, normal reaction, respectively, are. So you are having weight of the body 50 Newton and a force of 28.28 Newton is required to move it. Frictional force F is given by 28.25 into cos of 45 degree, right over here. So this is equal to 28.28 into cos of 45, 1 upon root 2. This will be equal to approximately 20 newtons. So this is the frictional force. Now the normal reaction also you have to calculate. Normal reaction R will be given by the total weight, that is the 50 newtons minus this 28.28, or you can say the frictional force. This is equal to 50 minus 20, that is equal to 30 newtons. This is your frictional force only. So you have 20 Newton and 30 Newton as the answer. Option B is the correct answer. Hope you understood that. Let's move to the next question. Question number 86. A block of mass m moving on a frictionless horizontal surface collides with a spring constant K as shown in the figure. If the spring compresses by the length L, then the maximum momentum of the block after the collision is. Okay. Total mechanical energy involved over here is the sum of kinetic plus the potential energy. Wait. Total mechanical energy is given by kinetic and potential energy. Now, this mechanical, because it is a frictionless horizontal surface, so this mechanical energy is conserved in this collision. Mechanical energy is conserved because it is a frictionless surface. So you have kinetic plus the potential energy initially is equal to kinetic energy plus potential energy finally. That means change in the kinetic energy plus change in U is equal to 0. And there is no change, and you have change in kinetic energy is equal to minus delta minus U, minus delta U. 86. A block of mass m moving on a frictionless horizontal surface collides with a spring of constant K. As shown in the figure, if the spring compresses by the length L, then the maximum momentum of the block after the collision is. You know that the mechanical energy, total mechanical energy, is given by the kinetic and the potential energy. Now, according to the question, the total mechanical energy of the whole system is conserved after the collision because it's a frictionless horizontal surface. Therefore, according to the question, total mechanical energy before the collision and after the collision is equal. Okay, that means delta K plus delta U is equal to 0, or you have delta K is equal to minus delta U. Now let's say the initial velocity be V. Then you have the first initial kinetic energy as half mv square, and the final potential energy will be given by half k x square. According to the conservation of the energy, you have half mv square is equal to half k x square, where x is your compression. In this question, you are given that the compression is equal to L. So you have some cancellations. You have V is equal to K upon M under the root into X. And X is equal to L. So V becomes equal to under the root K upon M into L. Therefore, maximum momentum is given by mass into velocity is given by mass into root of K into m upon multiply L. So this will be root m and n. This will cancel. So you will have L into root of m into k. Right. So here you have one more thing, that the mass m is given to you. So I'll convert this small m. This will be equal to m into k. Okay, there will be capital M. So you have option C as the correct answer. Hope you understood that. Next is 87 question. A body falls freely from a height h on a fixed horizontal plane and rebounds. If E is the coefficient of restitution, the total distance traveled before it comes to rest is. If a ball is dropped from the height h, then it will strike the floor with the velocity v is equal to root gh, where g is your acceleration due to gravity, and h is the height of fall. Right? Now, after striking the floor, it will bounce back with the velocity u is equal to ev. It is given. If e is the constant coefficient of restitution, then so after striking the floor, it will. This is the bounce back velocity is e times the initial velocity. Now it will travel a distance of. Now it will travel 2h distance before it again strikes the ground, where now h1 will be given by e square into v square upon 2g. Again the ball will bounce back. Again ball will bounce back with velocity e square v, and now it will travel distance of 2h2. Therefore, 2h2, h2 will be given by e, this is equal to e power 4 multiply v square upon 2g. Hope we are clear till here. Now this process, again it will go in the height and bounce back. Now this process will continue for long till the ball comes to rest. This process will continue till ball comes to rest. So the total distance traveled will be equal to, let's say d. This is equal to h1 plus 1 into h1, 2 into h2, and so on. This is equal to v square upon 2g plus 2 e square, v square upon 2g plus 2 e power 4 v square upon 2g plus 2 e power 6 v square upon 2g, so on. I'm taking this common, v square upon 2g. This will be e square, e power 4, e power 6, so on. Now this is a GP with a as 1 and the common ratio as e power 2. This is v square upon 2g plus 2e square v square upon g 1 upon 1 minus e square. Question number 87. A body falls freely from a height h on a fixed horizontal plane and rebounds. If e is the coefficient of restitution, the total distance traveled before it comes to rest is. When a ball is dropped from a height h, then it will strike the floor with the velocity. Let's say v is given by root of 2gh, where h is the height of fall. G is your acceleration due to gravity. Or you have h is equal to v square upon 2g. Now, after striking the floor, it will bounce back with the velocity after striking the floor. It will bounce back with the velocity v is let's say v is already taken. Let's say u is equal to ev. Okay, e is the coefficient of restitution and the v is your initial velocity with which it has hit the ground. Now it will travel a distance of 2h. Now it will travel 2h distance before striking again the ground. Before striking the ground again. Now here h1 is given by e square v square upon 2g. Again the ball will bounce back. Now again, actually this is the third time. Again the ball will bounce back with velocity. Let's I'm keeping it velocity only, E square V, and distance will be 2h2 now, because it has changed. The height will be changed. Now the distance is equal to 2h2. So h2 will be equal to, this is E power 4 upon V square upon 2g. This is the h2 now. So this will happen continuously. This process continues for long until the ball comes to rest. This process will continue till ball comes to rest. So the total distance traveled will be equal to d is equal to first h, then you had h1, then you had let's say 1 into h1, 2 h2 plus so on. So the total distance will be equal to, h was equal to v square upon 2g, plus this is equal to h1 was equal to e square v square upon 2g, e square v square upon 2g plus 2, h2 is equal to e power 4 v square upon 2g plus 2 into e power 6 v square upon 2g, so on. So this will be equal to v square upon 2g. I'm keeping it here, and also taking common from here. This will be, as a correction, there will be 2 over here, because when it bounces back, it will travel a distance of 2h1 actually. So over here, this will be, now I'm taking common, 2e square v square upon 2g. So this is 1 plus e square plus e power 4, so on. And now this is the GP series with a as 1 and r as e power 2. Or this is equal to v square upon 2g plus 2e square v square upon 2g. This will be this sum to infinity. This is given by sum is equal to a upon 1 minus r. This is the formula for the GP. So this is 1 minus e square, or I'm taking v square upon 2g common again. This will be 1 plus this will be 2e square into this. So let's open up this as well. This will be v square upon 2g, 1 minus e square plus 2e square upon 1 minus e square. This is equal to v square upon 2g into 1 plus e square, 1 minus e square. This is your h. So h into 1 plus e square upon 1 minus e square. This is the answer to the question. H into 1 is plus e square upon 1 minus e square. You have option A as the correct answer. Hope you understood that. Next is question number 88. Question number 88, two blocks of equal masses are tied to the end of a light string. So these are the two blocks which are having the equal mass m. The string passes over a massless pulley fixed on frictionless surface as shown in the figure. So this is a string which is attached to this pulley. The acceleration of the mass, center of mass of the blocks is, you have to take g as the acceleration due to gravity. So here it is, these are the two blocks with the equal masses. This component of the force is mg sine 60 degree, because this is 60 degree angle. And then here the component of the force is mg sine 30 degree. This is the tension in this direction. Tension, of course, for the string is in this direction for both of them. And this is acceleration with which this block will be moving up, because this is a longer string and this is a shorter one. So this is the acceleration with which both of them are moving. Now, mg sine 60 degree minus t is equal to the net force with which this object is moving. Because this is the component of the force which is acting in the downward direction, and this t is acting in the upward direction. So the component of force with which this object is moving is given by mg sine 60 degree minus t. That is equal to your force, or you can say this is equal to your mass into acceleration. Also, you have mg for this block. You have mg sine, since this is moving in the upward direction, so this is t minus mg sine 30 degree. This is equal to mass into acceleration. So from here, solving both of them, you have m sine 60 degree, mg sine 60 is root 3 by 2 minus t is equal to m into a, and here you have mg by 2 is equal to m into a. So from here you have t is equal to mg into root 3 by 2 minus m into a, or t is equal to mg by 2 plus ma. From both of them you have, they are equal, root 3 mg by 2 minus ma is equal to ma plus mg upon 2. I'm taking this like 2 ma is equal to mg. I'm taking common, root 3 by 2 plus minus 1. Okay, so you have a 2 into ma is equal to m, and n will cancel. I will write down twice of a is equal to g into root 3 minus 2 upon 2. Or you have a is equal to g into root 3 minus 2 upon 4. This is your value for the a. Now, if I'm taking the a1 vector for this, the a1 vector, let's take this a1 and this as a2. So a1 vector will be given by minus a cos 60 degree I cap minus a sine 60 degree j cap, and a2 vector will be given by minus a cos 30 degree I cap minus minus plus, this is a cos 30 degree j cap. So this will be equal to minus a by 2 I cap minus root 3 into a by 2 j cap, and for a2 this will be minus root 3 upon 2 a I cap plus a by 2 j cap. Right. So now you have to find out the acceleration of center of mass. Acceleration of center of mass will be given by, acceleration for the center of mass is equal to m1, that is the first mass, into a1 vector plus m2 into a2 vector divided by the sum of m1 and m2. So minus ma, this is common, right? M1 is m is same, so this will be given by ma upon 2. I'm writing for this factor, ma upon 2 1 plus root 3 I cap plus ma upon 2 1 minus root 3 j cap upon m plus m. This will be equal to 2m. So this will be equal to, I'm taking, m will cancel from this, and this. You will be left with, I'm taking a by 2 common from here, and 2 multiply by 2. This will be taken common, and inside you will be left with minus 1 minus root 3 I cap plus 1 minus root 3 j cap. Hope you are clear till here. Next, this will be given by, I have to find out the magnitude of it, right? So the magnitude for this acceleration for the center of the mass, this will be given by a by 4 will be taken outside, root of minus 1 minus root 3 whole square plus 1 minus root 3 whole square. This is the modulus under the mod. This is equal to a by 4 root of 1 plus 3 minus minus plus 2 root 3 plus 1 plus 3 minus 2 root 3. This and this will cancel. You have a by 4 upon 4 plus 4, that is 8. So this will be a into 2 root 2 upon 4, or you have a upon root 2. Now, the answer is given to you in the question and somewhat like this form. A upon root 2, what was a equal to? We just solved. A is equal to this. Is it small correction? This was mg by 2. So this was supposed to be 1 by 2 over here. So it will be minus 1. Hope you got this thing. I'm repeating, this was mg minus 2. So they were supposed to be 1 by 2. This will be root 3 minus 1. So let's fill this value of A over here. You have this will be equal to G into A was equal to root 3 minus 1 upon 4 into G. So this will be equal to G into root 3 minus 1 upon 4 root 2. This is the right answer to the question. And now let's check with the options. You have first option as the correct answer. Option A is the correct answer to the question. Hope you got that. Next is question number 89. A body is rolling without slipping on a horizontal plane. If the rotational kinetic energy of the body is 50% of its total kinetic energy, then the body is a hollow sphere, solid cylinder, or the thing, circular ring. You are given in the question that the rotational kinetic energy is equal to the 50% of total kinetic energy. And what is the total kinetic energy? It is the rotational kinetic energy plus your normal kinetic energy. This is your total. Like this is the rotational plus the linear kinetic energy. And rotational kinetic energy is given by half of moment of inertia into radius square, and key E for the linear one, this is half mv square. So let's pull both of these values in the first equation. You have this rotational kinetic energy. This is equal to I into omega square. This is omega square, not the radius square. This is I into omega square, where I is your moment of inertia and omega is angular velocity. In this question, m is mass of the body and v is linear velocity. All right. So now you had the equation, and starting from here, you had the rotational kinetic energy is equal to 50% of total kinetic energy. That means rotational kinetic energy, which is given by half into moment of inertia into angular velocity, is equal to 50 upon 100 of total, which is equal to half mv square plus half I omega square. That makes it like this is 1 by 2. And this will cancel. You will have I into omega square is equal to 1 by 2. I'm taking outside mv square plus I omega square. And you know angular velocity is equal to linear velocity square upon the radius square. I will write it as I into v square upon r square is equal to m v square, right? Yeah. This plus half into I into v square upon r square. I'll take this on the left hand side, and this will be equal to half I v square upon r square is equal to half mv square. Here was half will cancel. You will have I is equal to v square, and v square will also cancel. You will have I is equal to m into r square. So this is moment of inertia of a thin circular ring. Moment of inertia of thin circular ring. Let's check with the options. Then you have this as the right answer, option D. Hope you got that. Next is question number 90. A pendulum has a time period T in air. When it is made to oscillate in water, its time period becomes root 2T. Then the relative density of the material of the bob of the pendulum. You have to neglect damping over here. So the effective acceleration of the bob in water is given by effective acceleration of bob in water is given by G dash is equal to G1 minus this is a sigma upon rho, where sigma is your density of water and rho is density of the bob. So effective acceleration of the bob is given by in water is given by this equation. Since the period of oscillation of bob in air period of oscillation of bob in air is this, and in water it is root t by 2. So you will be given t is equal to 2 pi root of L upon G, or this is equal to 2 by L upon G dash, where we have also, this is for water and this is for let's say this is for air and let's say this is for water. So now you have t upon, dividing both of them, t upon t dash is equal to root of g dash upon G. Now fill in the values. You have G dash is given by G into 1 minus sigma upon rho divided by G, and G will cancel T upon T dash. So you have T upon T dash is equal to root of 1 minus sigma upon rho, or this is equal to 1 minus 1 upon rho. Because sigma is equal to 1, that is the density of the bob in water is equal, sorry, this is the density of water, yeah, density of water is equal to 1, so this sigma is equal to 1. Or you have t upon t dash is equal to 1 by root 2, because you know in the question that t dash is equal to 1 upon root 2 into t. So t upon t dash is equal to 1 upon root 2. So this thing is there. This is from, let's say, 1 and 2. You have 1 upon 1 minus 1 upon rho is equal to 1 upon root 2. Let's do squaring on both sides. So 1 upon 1 minus 1 upon rho is equal to 1 upon 2, or you have 1 by 2 is equal to 1 upon rho. That gives you rho is equal to 2. That's it. That's what we needed. We needed to know the density of the material of the bob. This is actually not the density of the bob. This is density of material of bob. Same, one of the same thing, nothing else. So you have option, let's check, you B as the correct answer. Hope you understood that. Let's move to the next question now. One, for an ideal gas at the temperature 26 degrees Celsius and constant pressure, the coefficient of the volume expansion is nearly. So you are given the temperature as 27 degrees Celsius and the pressure is constant. By the ideal gas equation, you have PV is equal to nRT, or you have 1 by T is equal to nR up into upon PV. Let's say this is equation 1. So now I'm taking this equation again. You have differentiating both sides with respect to T. You will have P into dV by dt is equal to N into R. This is differentiating both sides with respect to T. You have dV by dt, P into dV by dt is equal to nR, or dV by dt is equal to nR upon P. Now the coefficient of volume expansion is alpha V is given by V dV upon V into dt, or this is equal to, from this equation, I'm filling this value, okay. So nR upon PV is equal to, this is equal to 1 upon T from equation 1. Or you have the coefficient of volume expansion is equal to 1 upon T, and the temperature is given you 27 degrees Celsius. I'm converting that into Kelvin. This will be, I'll be adding 273 to it. So this is 1 upon 300 Kelvin, or this will be equal to 33 into 10 power minus 4 per Kelvin. This is the right answer to the question, and you have option D as the correct choice. Next is question number 92. The percentage increase in the energy for an artificial satellite to shift from an orbit of radius r to an orbit of radius 3r by 2. See the binding energy of binding energy F satellite, for the F satellite, is given by this PE is equal to G capital M small m upon R for radius R. And the next one, E dash is equal to 1 by 2 G M M upon 3 by 2 R. Because here you are given the new radius for radius 3R by 2. Let's do what we need to find the percentage increase. So if this is equation 1 and this is equation 2, first of all, let's find out increase in energy of satellite. So you have an increase in energy of satellite. This will be equal to GMM. Question number 92, the percentage increase in the energy for the artificial satellite to shift it from the orbit of radius R to an orbit of radius 3R by 2. Okay, see, the binding energy of satellite is given by PE is equal to, here you have half GMM upon R. This is when you're given that the radius is equal to R. And the second one, the binding energy for half GMM. Now the R is equal to 3 by 2R. This is for radius 3R by 2 in the second case. So you have to find out the percentage increase. First of all, this will be given by 1 by 3 into GMM upon R, because this 2, this and this 2 will cancel out. So first of all, increase in energy is given by, I'm taking GMM. This will be equal to PE dash minus PE. It will be PE minus PE dash. This will be, I'm taking P GMM upon R outside 1 by 2, 1 by 3 minus GMM R into 1 by 6, or this is equal to GMM upon 6R. You have to find out the percentage increase. Percentage increase is given by the increased value divided by the initial value, which is GMM upon 2R into 100. This cancels. This will be 3. And you have 100 upon 3. That is equal to 33.33%. So the answer to the question, option C. Hope you got that. Next is question number 93. The length of 4 wires A, B, C, D are made up of same material are 1 meters, 2, 3, and 4 meters respectively. The radii of the wires A, B, C, D are this much respectively. For the same applied tension, the elongation is more in which wire? Okay. I'll be using the Young's modulus of elasticity. Young's modulus of elasticity is given by Y is equal to force into length upon area into change in length. So change in length is given by force into length upon area into Young's modulus. So since we know that F upon Y is same for the same material. So the change in length will be directly proportional to length and inversely proportional to area. So let's consider for wire A now. Change in length will be directly proportional to length was equal to 1 and area is equal to pi into 0.2 10 raised to power minus 3 whole square, because this is pi r square. This is the radius given to for the line for the this 0.2. I'm converting that into meters. So 0.2 into 10 raised to power minus 3 area is pi r square. And for the wire B, you have, okay, let's solve this. This will be equal to 1 upon pi 0.04. Over here, this will be 10 raised to power 6. Okay, so this is 10 raised to power 6 meters over here. And for the wire B, you have a change in length directly proportional to length was equal to 2. Area is pi into 0.4, 10 raised to power minus 3 square. So this will be equal to 2 upon pi into 0.16. Here will be 10 raised to power 6 meters. And for the third one, the third wire, delta L will be equal to 3 upon pi into 0.6 into 10 power minus 3 square. This will be equal to 3 upon pi into 0.36. Multiply 10 raised to power 6. And for the D wire, you have delta L is equal to 4 upon pi 0.1 into 10 raised to power minus 3 square, or 4 upon pi into 0.8. It is equal to 0.8, not. So this will be 0.64 into 10 raised to power 6 meters. So that means from all of these values, it is very much clear. You will solve them. And this is very much clear that A is having the maximum elongation. This is the maximum one. So that means you have option A as the correct answer. Hope you understood that. Let's move to the next question. Question number 94. A liquid is taken in a long vertical cylindrical vessel and the cylinder is rotated about its vertical axis as shown in the figure. During rotation, the liquid rises along its sides. If the radius of the vessel is 0.05 meters and the speed of rotation is 10 per radians, then the height difference between the liquid at the center of the vessel and its side is what? You have to take the value of G as 10 meter per second square. In the question, you are given that the radius R is 0.05 meters and angular speed of rotation is 20 radians per second. And see, when the liquid is rotated, it reaches a certain height h. At this point, when liquid is rotated, the height h it reaches is given by h rho g is equal to 1 by 2 rho r omega whole square. So cancelling out rho and rho, you have h is equal to omega square r square upon 2g. Let's fill in the values. This is 10 square into 0.05 square divided by 2 into 10. This will give you 100 into 0.0025 upon 2 into 10. On solving, this will give you 125 into 10 raised to power minus 4 meters. That is option A as the correct answer. Hope you got that. Let's move to the next question. Question number 95. A vessel having small hole at the bottom has to hold water without leakage. If water is poured to the height of 7 centimeter, then the radius of the hole is what? Surface tension of the water is taken as this and the angle of contact is 0. You have to take the value of G as 10 meter per second square. So here in the question, you have H, that is your height, as 7 centimeter, which is converted into meters. You are having surface tension of water T, or S is equal to this 0.07 Newton per meter. You are having theta, that is the angle of contact, as 0. So now surface tension of water, surface tension of water membrane on the bottom, larger of the water will be given by T is equal to F upon 2 pi R, or this is equal to rho G H into pi R square upon 2 pi R. This will give me rho G, this will cancel, rho G H r upon 2. Now, here r is radius of the hole. R is radius of the hole. So r is equal to 2t upon rho gh. Right. So let's fill in the value. R is equal to, this will be 2 into 0.07 divided by rho is also this, multiply 1000, multiply 10. This will give you 2 into 10 raised to power 4 minus 4 meters, or this is equal to 0.2 millimeters. That means you have D option as the correct answer. Hope you got that. Let's move to the next question now. Question number 95. A vessel having small hole at the bottom has to hold water without leakage. If the water is poured to the height of 7 centimeter, then the radius of the hole is, you have to take the surface tension of the water as this, angle of contact as 0, and G as this value. In the question, you have height h is 7 centimeters, which is equal to 7 into 10 raised to power minus 2 meters. Also, you have the surface tension of water. It is given to you at 0.07 Newton per meter. Angle of contact is equal to 0, that is theta. Let's say angle of contact theta is equal to 0. I think I've written everything. You have to take the G's value as 10 meter per second square. So now surface tension of water membrane on the bottom layer of water will be given by T is equal to F upon 2 pi R. F is rho G H into area of the bottom, and this is the circumference of the bottom. So this is divided by 2 pi R. R will cancel, pi will cancel. This will be rho G H R upon 2. So you will have here R is your radius of the hole. So R is equal to 2t upon rho G H, or this is equal to T's value is 0.07. Rho is approximately, I'm taking 100 because it's actually 997. So approximately 100 value, G is 10. H is 0.07. Doing the cancellations, you have 2 into 10 raised to power minus 4 meters, which on conversion to millimeters, because the answer is in millimeters, this is 0.2 mm. That makes option D to be the correct answer. Hope you got that. Let's move to the next question. Question number 96. Air is filled at 60 degrees Celsius in a vessel of open mouth. The vessel is heated to a temperature of 3 degrees Celsius, so that 1/4 of the air is escaped from the vessel. Assuming that air is the ideal gas and the volume of the vessel remaining constant, what is the value of the temperature T? So here in the question, you are given the two temperature. The first temperature is equal to 60 degrees Celsius, or this is equal to 60 plus 273. This is equal to 333 Kelvin. And the second temperature, that is equal to T degree Celsius. Let it be that only. Also, one more thing that let's say initial mass M1 is equal to M, then final mass, because 1/4 of the air has escaped, so final mass, let's say that is M2. This is equal to M minus M by 4, because 1/4 has escaped, so this is equal to 3 by 4 of M. Hope you're clear till here. Now, if the pressure and volume, assuming that volume of the volume of the vessel remains constant. So if pressure and volume of the vessel remain constant, you are given in the question that it is an ideal gas. Two things, ideal gas and the volume remains constant. So that means if pressure and volume remain constant, then that means mt will remain constant, or m is inversely proportional to t. Therefore, if I'm dividing T1 by T2, this will be equal to M2 upon M1. T1 is equal to 333 Kelvin upon T2. T2 is equal to T is equal to M2 was 3 by 4 of M divided by M. M and N will cancel. You will have 333 is equal to 3 by 4 into T, or you have 333 on this is equal to T. So this is equal to 444 Kelvin. Now all the options are there in Celsius. Let's convert this into Celsius. So T is equal to 444 Kelvin. That's equal to 444 minus 273. That is equal to 171 degree Celsius. That makes option B to be the right answer. Hope you understood this. Let's move to the next question, number 97. If the temperature of 100 gram of water is to be raised from 24 degrees Celsius to 90 degrees Celsius by adding steam at 100 degrees Celsius to it, the mass of the steam required in this process is what? Also, the latent heat of steam is 540 calories per gram. You are given in the question mass of water as 100 gram and change in temperature. It has moved from 90 to 24 to 90. So this is equal to 66 degrees Celsius. This is the change in temperature. And from the principle of calorimetry, heat gained by water is equal to heat lost by steam. So this means MW into S MW into S into delta T, or this is equal to M steam into 540, and delta T is given by temperature of 100 gram of water is to be raised from 24 degrees Celsius to 90 degrees Celsius by adding steam at 100 degrees Celsius to it. The mass of the steam required in this process is what? We have to take the latent heat of steam as 540 calories per gram. So first of all, let M be the mass of the steam required, mass of the steam required to raise the temperature of 100 gram of water from 24 to 90 degrees Celsius. So the heat which will be lost by the steam will be equal to heat gained by the water, right? Therefore, you have M into L plus S into delta theta 1 is equal to 100 into S into delta theta 2. Here M is equal to this M. Yeah, this is the M. So this M is equal to 100 into S into delta theta 2 divided by L plus S into delta theta 1. Here in this particular equation, S is your specific heat of water, which is equal to 1 calorie per gram. And your L is latent heat of vaporization, that is equal to 540 calories per gram given in the question, and delta theta 1 is 100 minus 90, that is equal to 10 degrees Celsius, and delta theta 2 is 90 minus 24, that is equal to 66 degrees Celsius. Now let's substitute all these values in this equation. You will have M is equal to 100 into 1, delta theta 2 is 66 divided by L is 540 plus S into delta theta 1, which is 10. This makes it 6600 upon 500 and 50, which is equal to 12 grams. So that means 12 gram of steam is required for this process, and we have D option as the right answer. Hope you understood. Next is question number 98. Two identical containers A and B with frictionless pistons contain the same ideal gas at the same temperature and same volume. The mass of the gas in A is MA, in B is MB. The gas in each cylinder is not allowed to expand isothermally to the same final volume 2V. The changes in the pressure of the gases A and B are found to be 2 delta P and 3 delta P respectively. You have to find out the relation between MA and MP. Okay, first thing, you are having isothermal process over here. For the isothermal processes, temperature will remain constant. For isothermal process, temperature remains constant. So volume is increasing in this question. If volume is increasing, then pressure will decrease. Why? Pressure is inversely proportional to volume. So if volume is increasing, pressure will decrease, or if volume is decreasing, pressure will increase. Now in the chamber A, the change in the pressure, this is given by initial pressure minus final pressure. And PV is equal to nRT. This is an ideal gas. PV is equal to nRT. So P will be given by NART upon V, because for the initial one, both are having the same volume V. And for the final one, it is NART. Now the volume has become 2V. See? Yeah. Final volume 2V. So this is equal to 1 by 2 into NART upon V. Now this is similarly for the chamber B, you have delta PB is equal to PB initial minus PB final, which is equal to NBRT upon V minus NBRT upon 2V, which is equal to 1 by 2 NBRT on V. Right, so I have these two equations. Now in the question, it is given that the changes in the pressure in A and B are found to be 2 delta P and 3 delta P. That means, according to the question, delta PA upon delta PB is equal to 2 by 3. So I'm using from here, let's say this is equation 1, equation 2, dividing 1 and 2. You have delta PA upon delta PB, this will be equal to NA upon NB. See, when you will divide this with this, only NA and NB will be left, rest all will cancel out. And this is equal to 2 by 3 from here, right? Therefore, what is NA? Just, yeah. NA is given by 2 MA upon M divided by 2. This is equal to, I'll leave this one. Na is equal to the given mass upon the molecular mass. And similarly, for this, it is Ma upon M upon Mb upon M. This is equal to 2 by 3. M and N will cancel. So you will have Ma upon Mb is equal to 2 by 3. So this is equal to 2:3. And okay, you are having some this type of relation. So this can be written as 3 MA is equal to 2 MB. So this is the right answer to the question. 3M is equal to 2 MB. You have option B as the correct answer. Hope you understood that. See over here, one thing I would like to clear, that this M and this M, they are same, because in the question it is told that you are using the same ideal gas. So the molar mass for the molecular mass for the two gases will be same. Hope you got that. Let's move to the next question now. Question number 99. If the seventh harmonic of the closed organ pipe is in unison with the fourth harmonic of an open organ pipe, then the ratio of the length of the closed pipe to that of the open pipe is. See, for a closed organ pipe, you have frequency let's say the frequency is given by mu1. This is equal to frequency upon 4L1. And for the seventh harmonic, this is equal to 7 upon 4L1. Right, let's say this is equation 1. And for, see, now we are talking about the open organ pipe. For an open organ pipe, you have mu2 is equal to mu upon 2L2. And for the fourth harmonic, it is for fourth harmonic, this is equal to 4 mu upon 2L2. Right. Now, according to the question, it is they both are in unison. Let's say this is equation 2. Now, according to the question, you have 7 mu1 is equal to 4 mu2, or let's write that was equal to upon 4L1. This is equal to 4 mu upon 2L2. So this will cancel, and this will cancel. So you will have this will be L1 upon L2 is equal to 7 upon 8. Or this is having the ratio 7:8. That makes option D to be the correct answer. Hope you got that. Let's move to the next question. Question number 100. An observer moves towards a stationary source of sound with a speed of 1/5 of the speed of the sound. The apparent increase in the frequency heard by the observer is, all right, see, the apparent frequency is given by, let's say that's f dash, that is your frequency, multiplied by speed of sound plus speed of the observer, divided by speed of sound minus speed of the object source. So this is f dash is equal to f, and this is, you are given that the speed of the observer is 1/5 of the speed of the sound. So that means VO is equal to V by 5. So this is V plus V by 5, and speed, because it is a stationary observer, that means Vs is equal to 0. So this is the one. Right, so this is f upon 6 by 5 into V upon V. These two things cancel. That means you have f dash is equal to 6 by 5 into f naught. Now, what you have to find out is percentage increase in frequency. Percentage increase in frequency is given by increase in frequency, that is equal to 6 by 5 f naught minus f naught upon the original frequency, which is f naught, into 100. This is equal to 1 by 5 f naught upon f naught into 100, or you have 100 upon 5, that is equal to 20%. Right. So this is it. You have the option as the right answer. Hope you got that. Next is question number 101. Refractive index of a medium is mu. If the angle of incidence is twice that of angle of refraction, then the angle of incidence is, fine. So you are given refractive index of the medium. So that means you have a mu is equal to sine of angle of incidence upon sine of angle of refraction. You are given that angle of incidence is twice the angle of refraction. So that means I is equal to 2r. So this makes it sine 2r upon sine r. And sine 2r is sine 2 sine r cos r divided by sine r. These two things will cancel. So you have 2 cos r is equal to mu, or you have cos r is equal to mu upon 2, or r is equal to cos inverse mu upon 2. Right, what you have to find out is angle of incidences. That means you have to find out r. Okay, you know I is equal to 2r. It's given in the question. Let's fill in the value over here. So I is equal to 2 into cos inverse mu upon 2. That makes option C to be the right answer. Hope you got that. Next is question number 102. Two slits are made 1 millimeter apart and the screen is placed 1 meter away from the slits. The fringe width when the light of wavelength is 500 nanometer is used is. Let's write down all the things you are given. First of all, two slits are 1 mm apart. So that means D is equal to 1 mm, or this is equal to 10 raised to power minus 2 meters. Minus 3 meters. Then the screen is placed 1 meter away. So that means capital D. Let's keep it capital D. So capital D is 1 meter away. That's it. And you are given the length lambda, that's wavelength, as 500 nanometers. This is equal to 5 into 10 raised to power minus 7 meters. You have to find out the fringe width. This is given by D lambda, capital D lambda upon small d. This is 1 into 5 into 10 raised to power minus 7 upon 10 raised to power minus 3. This is 5 into 10 raised to power minus 4 meters, right? Or, but I don't have this thing. But now this can be written as 0.5 into 10 raised to power minus 3 meters, or wait. This is equal to 0.5 millimeters. So this is the right answer to the question, 0.5 millimeters. You have option B as the correct answer. Hope you got that. Next is question number 103. The flux of the electric field is given by this Newton per coulomb through the area of 20 meter cube on the YZ plane. Okay, so let's write down the things which are given to us. You are having the electric field vector as 24I, 30J, 28K. Also, you are given that the area is equal to 20 meters square and in the YZ plane. So if I write this area in the vector form, this is 20I, because in the YZ plane, Y and Z will not be there. So it will be 20I only. Okay. You have to find out electric flux. This is given by the product of the electric field into the area. And this is 24I, 30J, 28K, the dot product with 20I. So this will be 24 into 20. I square, this is the unit vector, so I square will be 1 plus 30 into 0 plus 28 into 0, because Y and J are missing over here. J and K are missing over here. Over here. This is equal to 480 Newton meter square per coulomb. So this is the answer to the question. Let's check with the options now. Here you have option A as the correct answer. Hope you got that. Let's move to the next question now. Question number 104, the effective capacitance between the points A and B is given in the figure. So you have to find out. Okay, these are the points A and B in the given figure. You have to find out the effective capacitance. Let's name this as C1, C2, C3, and C4. Now, effective capacitance between A, B is given by the product of C1, C2 divided by their sum, plus the product of C3, C4 divided by their sum again. So all you have to do now is just fill in the values. C1 is equal to 20, multiply 20 upon 20 plus 20 plus 10 into 10 upon 10 plus 10. This is equal to 400 upon 40 plus 100 upon 20, or that is equal to 15 microfarad. That makes option B to be the correct answer. Hope you understood that. Next is question number 105. The electric resistance of a certain wire of iron is capital R. If the length and radius both are doubled, then how will the resistance change according to these given options? First thing, the resistance is direct. Okay, you will say resistance is directly proportional to length and inversely proportional to area. So here the resistance is given by rho into L upon A, where L is the length, A is the area, and okay, rho, here is your rho. Next is question number 105. The electric resistance of a certain wire of iron is R. If length and radius both are double, then how will the resistance change? Okay, first thing, the resistance is directly proportional to length and inversely proportional to area. That means resistance is equal to rho into L upon A. This is resistivity, length, and area. Right, so you're having the two resistances. If I say R1, this is equal to L1 upon A1, rho into L1 upon A1, and R2 is equal to rho into L2 upon A2. Let's divide both of them. You will have R1, R2 upon R1. So you will have R2 upon R1 is equal to R. See, this is equal to, if I look it into area, this is equal to pi R1 square, and this is equal to rho into length 2 pi R2 square. Okay, so this makes R1 upon R2 whole square into L2 upon L1. Right, rho and rho will get cancelled. Now, in this question, R1 is equal to R and R2 is something I have to find out. Okay, one more thing, L2 is equal to twice of L1 and R2 is equal to twice of R1. Okay, so from filling in all these things in this equation, you will have R2 upon R1 is equal to R1 upon 2 R1 square into 2 L1 upon L1. So this thing will cancel, this will cancel, and you will have R2 upon R1 is equal to 1 by 4 into 2, or this is equal to 1 by 2. Or you have R2 is equal to R1 by 2. R1 is actually R, right? We discussed this thing. So this is R by 2. Since the specific resistance does not depend on the dimensions of the wire because it depends only on the nature of the material of the wire and temperature. So the correct answer to the question, the resistance will be halved and the specific resistance will remain unchanged. This is option B. Hope you understood that. Next is question number 106. In a meter bridge experiment, the ratio of the left gap resistance to the right gap resistance is 2:3. The balance length from left end is. Okay, see, we know that in a meter bridge, our left upon our right is given by length upon 100 minus length. Now, in this question, you are given that the ratio of the left gap resistance to the right gap resistance is 2:3. So this is equal to 2:3. This is L upon 100 minus L. This makes 200 minus 2L is equal to 3L, or L is equal to 40 centimeters, right? That makes option D to be the correct answer. Hope you understood this. Next is question number 107. A charge Q moves with a velocity of 2 meters per second along x-axis in the uniform magnetic field given by this. Then the charge will experience a force of. All right, so here you are given the magnetic field as this factor 2I, 2J, 3K, T. And you are given the velocity as 2 meter per second in along x-axis. So that means the velocity is equal to 2I meters per second, right? Now you have to find out the force. Force on the charged particle is given by F is equal to Q into the cross product of V and B vector. So this is Q, this is 2I cross 2I, 2J, 3K. So yes, this is equal to Q and 2I cross product, this will be 0. because they are having a 0 degree between them, and sine of 0 degree is equal to 0. So, and you have 2i, 2j, this will be 2k, because the cross product of I and j, it will give you k, and this will be minus 6j, right? Because I and k is here, so it will be minus 6j. And let's write it properly again. You have 4k minus 6j, or this. Right. This is your force, and this is the right answer. Now, the above expression of force, it is clear that the charge will experience a force in YZ direction because X is missing over here. It will experience a force in YZ direction. That makes first option as the correct answer. Hope you got that. Let's move to the next question, number 108. In a galvanometer, 5% of the total current in the circuit passes through it. If the resistance of the galvanometer is G, the shunt resistance is connected to the galvanometer is how much? Let's understand this. You are having a galvanometer over here, and the current I is passing. This is the shunt resistance. And here is IG current passing. There is I, and here you have I minus IG. Right. So, okay. See, now according to the given condition, given question, you are having IG as 5% of the total I, or this is equal to 0.05 of I, and I minus IG, this is equal to I minus 0.05 I, which is equal to 0.95 I. Now, let's apply Kirchhoff's voltage law. In the loop, you will get I minus IG into S, because this current is passing through S, plus minus IG into G, that is the resistance of the galvanometer. This is equal to 0. Let's write it again. I minus IGS. This is equal to IGG. And let's fill in the values. This was equal to 0.95 I into S is equal to 0.05 I into G. Or you have to find out. This will be S is equal to 0.05 I into G upon 0.95 I will cancel, and you will get this G upon 19. So S is equal to G upon 19. You have B option as the right answer. Hope you got that. Let's move to the next question, 109. Material suitable for permanent magnets must have which of the following properties? Okay, see, material suitable for making permanent magnets must have these properties, like they should have first thing, high retentivity, so that it produces a strong magnetic field. The second thing, this is the first one. So the second thing, high coercivity, so that magnetism is not destroyed by stray magnetic fields, temperature variations, or minor mechanical damage. Third thing, high permeability. See, in spite of slightly smaller retentivity than soft iron, steel is favored for making permanent magnets. Steel has higher corrosivity than soft iron. Magnetization of steel is not easily destroyed by stray fields. Once magnetized under a strong field, it retains its magnetization for a long duration. That makes D option as the correct choice for the question. Hope you got that. 110, the expression for the magnetic field stored in the solenoid of length L in terms of magnetic field B and area A is. Fine. So we know that magnetic energy stored in a solenoid per unit volume, it's given by U upon V is equal to 1 upon 2 into V square upon mu naught, where mu naught is the permeability of the free medium. And you will have U is equal to half into B square into V upon mu naught. You know that volume is equal to area into length. So I'll fill in half into B square into AL upon mu naught. This is the answer to the question, and first option is the right answer. Hope you got that. Next is question number 111. An aeroplane is traveling horizontally towards the west with a speed of 540 km per hour. The wingspan of the plane is 20 meters. If the horizontal component of the Earth's magnetic field at the location is this much and the dip angle is 30, the potential difference developed between the ends of the wing is. Okay, first thing you are given the speed of the aeroplane is this. Speed of aeroplane 540 kilometer per hour. Let's do the conversion 540 into meters per second. So this will be a total of 150 meters per second. Also, length of wingspan 20 meters. Also, you're given the horizontal component of the Earth's magnetic field is this much. So BH is 2.5 root 3 into 10 raised to power minus 40. Dip angle is 30 degree, right? If BH is this and dip angle is this, that means the vertical component of the Earth's magnetic field will be given by BH into tangent of the dip angle. So this is 2.5 root 3 into 10 power minus 4 into tangent of 30 degree. This will be 2.5 root 3 10 power minus 4 upon into 1 upon root 3. This will be 2.5 into 10 raised to power minus 4 t. Now, you have to find out in the question potential difference developed between ends of the wing. Right. So this is given by V into VL, and B we just calculated. This is this 2.5 into 10 raised to power minus 4 it was. Let's check once. Yes, 2.5 into 10 raised to power minus 4. Speed is 150, we just calculated, and the length was equal to 2. So let's solve this whole thing. This will be 2 by 25 by 5 into 330, 3000 into 10 raised to power minus this. So this will be equal to 75 into 10 raised to power minus 2, or this will be equal to 0.7 volt. That makes option C to be the correct answer. Hope you got that. Let's move to the next question now. Question number 112. A series LCR circuit is connected to an AC source of voltage 150 sine 80 pi t volt. If the resistance of the resistor in the circuit is 25 ohm and the impedance in the circuit is 75 ohm, the average power dissipated per cycle in the circuit is placement current through the plates of a parallel plate capacitor of capacitance 30 microfarad is 150 microampere. The capacitor is charged by a source of varying potential at the rate of. In the given question, we are talking about the displacement current, and we know the displacement current is given by E naught. Wait, displacement current is given by E naught into change in the magnetic flux upon dt, d phi upon dt. This is your permittivity of free space, and this is change in your magnetic flux. So this is equal to E naught d. Flux is equal to electric field into area. So I'm using it over here, E into A, and the area is constant. I'm taking it outside. This will be dE upon dt. And you know electric field is V upon D. So I will write it over here. D V upon D. Wait. Dt of V upon D. Now D is constant. I'm taking it outside. This will be dV by dt. Let's put this thing. You know, this is equal to capacitance, that is C. This is equal to capacitance. So your displacement current is equal to, it becomes equal to C into dV by dt. Or you have dV by dt is equal to ID upon C. Now in this question, you have the displacement current as 150 microampere and the capacitance is given to you as 30 microfarad. Let's use this thing. dV by dt is equal to, this is equal to 150 microampere. Let's convert it. This is equal to 1.5 into 10 raised to power minus 4 ampere, and this is equal to 3 into 10 raised to power minus 5 farad. So this is 1.5 into 10 raised to power minus 4 upon 3 into 10 raised to power minus 5, which is equal to 5 volt per second. So this is the answer to the question, and let's check with the options now. Here you have option C is the correct answer. Hope you understood that. Next is question number 114. The de Broglie's wavelength of a particle moving with a speed of 0.8 c is equal to the wavelength of the photon. If c is the speed of the photon in vacuum, the ratio of energy of the photon and the kinetic energy of the particle is. So you're given here speed of the moving particle. Let's write speed of the moving particle V is equal to 0.8 c. We know that de Broglie's wavelength associated with the moving particle. For this, the lambda is given upon as h into m into h upon m into v. So this is equal to v is given to, I don't know about m, but v is given to you as 0.8 c. Now, de Broglie's wavelength of photon. Let's write it here. De Broglie's wavelength of photon, you have lambda is equal to h upon m into c. Here E is equal to energy of photon. E is equal to hc upon lambda. So the kinetic energy of particle E dash is equal to half mv square. Therefore, you have half m. V is 0.8 c square is equal to, this will be equal to 0.3 c, 0.32 mc square. Right. Let's do the division of these two things. You will have E upon E dash is equal to hc upon lambda upon 0.32 mc square. This is equal to h c, and c will cancel over here. So you will have h upon lambda into 0.32 m into c, or this is equal to h divided by h upon m into 0.8 c into 0.32 m into c. I'm using here this previous equation, this one, using equation 1. Okay, so now further, this is equal to, on solving this whole thing, h and h will cancel, and here m and m will cancel, c and c will cancel. You will have 0.8 upon 0.32, or this will be equal to 5:2. So this is the answer to the question, 5:2. Option B is the correct answer. Hope you understood this. Let's move to the next question then. Question number 100. 15. In a hydrogen spectrum, the shortest and the longest wavelength of Balmer series are lambda 1 and lambda 2 respectively. The Rydberg constant for hydrogen is, okay, see, in the hydrogen spectrum, for the shortest in hydrogen in, wait, hydrogen spectrum, for the shortest wavelength of Palmer series, you have N1 is equal to 2 and N2 is equal to infinity. That gives you 1 upon lambda for the Palmer series is R 1 upon 2 square 1 upon infinity. That gives you 1 upon lambda BS is equal to R upon 4. Now, for the longest wavelength, for the longest wavelength of Palmer series, you have N1 as 2 and N2 as 3. So that means 1 upon lambda BL is equal to R 1 upon 2 square minus 1 upon 3 square. Okay, this gives you 1 upon lambda BL is equal to R 1 upon 4 minus 1 upon 9. That is equal to 5 upon 36 into R. Right, let's say this is equation 2 and this is equation 1. So not dividing, I'll subtracting 2 from 1. You will get 1 upon lambda. I'll subtract 1 from, wait, yeah, okay, 1 upon lambda, 2 from 1. BL upon 1 upon lambda BS. Wait. This is, I'm subtracting 2 from 1. So this is 1 upon lambda BS minus, I'm rewriting this thing, 1 upon lambda BS minus 1 upon lambda BL is equal to R upon 4 minus 5R upon 36. So you have 1 upon, this is lambda 1 and this is lambda 2 is equal to this. I'm taking R outside, R by 4 outside. So 1 minus 5 upon 9. This is R by 4 into 4 by 9, or this will be equal to, let's, 1 by this upon this is equal to R upon 9. Okay, or R is equal to 9 upon lambda 1 minus 9 upon lambda 2. This is the right answer to the question. We have C option as the correct answer. Hope you got that. Next is question number 116. The alpha decay of the parent nucleus X results in the daughter nucleus Y. If mx, my, and alpha are the masses of the parent nucleus, daughter nucleus, and the alpha particle respectively, then the net kinetic energy gained in this process is. So you are having that X decay results in Y and alpha particles. Let's write out. According to this, you have X gives you Y plus the alpha particles. So the mass effect will be given by delta M will be given by the mass of X minus mass of Y minus mass of alpha particle. So net kinetic energy gained in this process is equal to energy released in the nuclear reaction, right? And how much is that? It's given by the change in mass into C square, which is mx minus my minus m alpha into C square. This is option B. So this is the right answer to the question. Hope you understood that. Next is question number 117. In the nuclear fusion of one nucleus U-235, the energy released is 188 mega electron volt. The energy released in the nuclear fission of 235 gram of U-235 is nearly, you have to take the Avogadro's number as this. See, first of all, the energy released, let's say this is E, is 188 mega electron volt. I'll convert 188 into 1.6 into 10 raised to power minus 13. This is the charge on an electron. So this is this much volt. See, charge on an electron is 1.6 into 10 raised to power minus 19. Mega gives you 10 raised to power 6. So this will be equal to 1.6 into 10 raised to power minus 13. Okay, this is the electron charge. And hope you are clear with this. So now E is equal to, E becomes, I'll let the E only this be. Total energy released will be equal to the number, the energy released, okay, total energy released will be the number multiplied by the energy released by one nucleus. So this is the one. N is your Avogadro's number. To 10 raised to power 23 into 188 into 1.6 10 raised to power minus 13. This is equal to 1810.8 into 10 power 10 or 18.10 into 10 power 12 joules. This is the answer to the question. Option B is the right answer. Hope you understood. Next, question number 18. The phase difference between the input voltage and the output voltage in a common emitter is. See, in a common emitter, amplifier, wait, in a common emitter, in a common emitter amplifier, output voltage is 180-degree out of phase of input voltage. That makes D option to be the right answer. Hope you understood. Next is question number 119. The built-in potential of a PN junction diode is 0.7 volt. If the diode is forward biased and the applied voltage is this much, the effective barrier height is. Okay, see the effective barrier height. Wait, okay, sorry. I'll write it again. Effective barrier height is given by barrier potential minus applied voltage. This is 0.7 volt and applied voltage is this. So the answer is 0.4 volts. Simple as that. Option C is the right answer. Hope you got that. And with that, let's move to the last question of the paper. The loss of strength of a signal while propagating through a medium is known as. See, the loss of strength of a signal while propagating through a medium is known as attenuation. The right answer is option C. And if I talk about the first one, modulation, this is the process in which characteristics of carrier wave is changed according to the modulating signal. Right. And if I talk about the demodulation, is the process of separating the original message signal from the modulated signal. And last one, the noise, unwanted signal. Or unpleasant signal. So we have option C as the right answer to the question. So students, with that, we have completed all the 40 questions of physics for this paper. Hope you understood them well. And don't forget to visit our website, www.examsnet.com. Here you will find so many entrance exam question papers along with the detailed PDF solutions. Also, you must download our app. The link is available in the description box for a better preparation of your exam. So keep shining, keep rising high. That's all for this paper. Bye. Hey, Shamsi of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. Here you will find not only this, but so many entrance exam question papers for your better preparation. Also, you must download our app. The link is available in the description box. So students, are very best of luck. Today we'll be solving TS EAMCET Engineering 30 May 2023. Shift 1 paper. I'll be solving the chemistry questions in this particular paper, in this particular video. So students, a very best of luck. Here we go. The first question of chemistry, question number 121, it says the radius of the first Bohr orbit of hydrogen atom is same as that of orbit N of hydrogen-like species X, N and X respectively are. Okay. So it's talking about the Bohr orbit of hydrogen atom. So Bohr's radius of nth, Bohr's radius of nth orbit is given by Rn is 0.529 n square upon z angstrom, where n is your energy level and z is atomic number. Z is atomic number. So first Bohr orbit of hydrogen atom . For this, n is equal to 1 and z is also equal to 1. So radius of hydrogen atom RH is equal to 0.529 angstrom. For helium ion, you know, n is equal to 2. Atomic number is also equal to 2. So radius of this ion is equal to 0.529 multiplied by 2 square upon 2, or this is equal to twice of radius of hydrogen for lithium ion. We have just seen for the helium. I'm going for the lithium now. So for the lithium ion, this is 2 plus, you have R of radius of lithium ion is equal to, see for the lithium ion, you have N is equal to 2 and atomic number is 3. So this is 0.529 multiply 2 square upon 3, or this is 4 by 3 of radius of hydrogen. And for the beryllium ion, you have N is equal to 2 and atomic number as 4. So radius of this ion is equal to 0.529 2 square upon 4, or this is equal to RH only. Right. Now for the beryllium ion, N is equal to 2, has same radius as the hydrogen atom, has same radius as that of first Bohr's orbit of hydrogen atom. Therefore, N is equal to 2 and X is equal to the beryllium ion. So this is the right answer. C is the correct option. Hope you understood that. Let's move to the next question. Question number 122. Identify the impossible quantum number set for the electron from the following. So if I look closely at this one, when I choose the option C, where n is equal to 2, L is equal to 3, M is equal to 1, and S is equal to 1 by 2 is impossible set of quantum numbers. When the principal quantum number n is equal to 3, the possible azimuthal quantum numbers will only be 0, 1, and 2, which represents S, P, and D orbits respectively. So this is the wrong one. Option C is the correct answer to the question. Hope you understood. Next is question 123. You have to choose the correct order of second ionization enthalpies of carbon, nitrogen, oxygen, and fluorine. See, the correct order of second ionization enthalpy is given by first you have oxygen. Let's write it properly. Order of second ionization enthalpies is given by first you have oxygen followed by fluorine, nitrogen, and last you have carbon. Electronic configuration of elements after removal of first electron will be O positive, F positive, N positive, and C positive. So this configuration will be first S 1s square, 2s square, 2pq, and 2p3 actually, 1s2, 2s2, 2p4, 1s2, 2s2, 2p2. And this is 1s2, 2s2, 2p1. Okay, so what you have to do is second ionization energy of oxygen is more. Second ionization energy of oxygen is more as it acquires a half-filled stable electronic configuration. So require a lot of energy to remove electron from oxygen. Carbon has least ionization energy. This one has most ionization, second ionization energy. And this one, carbon, this has the least carbon, carbon has the least ionization energy as it will remove one electron to attain a stable, fully filled configuration. This one. So you have option, you have option D as the correct answer. Hope you understood that. Let's move to the next question. Question number 123, you have to choose the correct order of second ionization enthalpies of carbon, nitrogen, oxygen, and fluorine. Well, the correct order of second ionization enthalpy is given by oxygen, followed by fluorine, nitrogen, and carbon. The electronic configuration of these elements after the removal of their first electron will be given by, like I'm removing only one electron from oxygen, so it will be O positive, 1s2, 2s2, 2p3. And for fluorine, this is 1s2, 2s2, 2p4, and nitrogen, carbon for nitrogen 1s2, 2s2, 2p2, and 1s2, 2s2, 2p1. Now, see, the second ionization energy of oxygen is more as it acquires a half-filled stable electronic configuration. So require a lot of energy to remove electron from oxygen. Carbon has the least ionization energy. It has the most ionization energy. So carbon is having the least ionization energy as it will remove one electron to attain. Only one electron is needed to remove or to attain the stable, fully filled configuration, whereas in oxygen, it is like it requires quite a lot of ionization energy as it requires half-filled stable electronic configuration. That makes option, it is oxygen fluorine. Yeah, and you have option D as the right answer. Hope you got that. Next is question number 124. From the following, identify the ions with the same bond order. So what is the, which are the two ones which are having the same bond order? Species containing same number of electrons have the same bond order. Same number of electrons, this is the same bond order. And for this is negative, Cn negative, it is having 14 electrons. 6 from carbon, 1 from nitrogen, and plus 1 for 1 from this negative charge because it has gained 1 electron. So this is a total of 14. And for N2 positive, and nitrogen is having 7 atomic number. So 7 into 7 minus 1, because there is a plus, that means 1 electron has been removed from it. So this is equal to 13. Next one is O2 to negative. This is having 18 electrons. And this is 8 into 2 plus 2. So this is equal to 18. And the last one, that is NO positive. Nitrogen is having 7. This is having 8 minus 1. That gives you 14. Okay. So this is having 14 electrons, and Cn minus and NO positive. That means 1 and 4. Option C is the right answer. Hope you understood this. Next is question number 125. The hybridizations of central atom of the molecules BF3, BEF2, BRF3 are respectively. See the hybridization, let's write down. Hybridization is given by is 1 by 2, V plus X minus C plus A. Where V is your number of valence electrons, X number of monovalent atoms around central atom. C is the positive charge on cation, and A is the negative charge on anion. Now the given molecules are these three. Let's write down for the first one, BF3. This is your molecule. This is V, X, C, A, and hybridization. So this is having V is equal to number of valence electrons. That's 3. X is 3, 0, 0. So this is half into 3 plus 3. That is equal to 3. So this is sp2. The next one, BEF2. V is 2 in this case. X is 2 again. And no charge. So this is 2. So that means hybridization is sp. Next is BRF3. So V in this case, number of valence electron is 7. This is 3, 0, 0, half. 7 plus 3, this is equal to 5. So this is sp3d. Now the question was the hybridization of the central atom in the molecule. This is R respectively. So this is sp2, sp. Let's see once again, sp2, sp, and sp3d. That matches with the first option. Hope you got that. Next is question 126. The ratio of rate of diffusion of gases X and Y of the molecular weight 36 and 64 is. Rate of diffusion is given by. Rate of diffusion is inversely proportional to the root of 1 upon the molecular mass. So for X, rate of diffusion will be given by root of 1 upon 36. That means this is the rate of diffusion for the X is inversely proportional to 1 by 6. Let's say 1. So similarly for Y, rate of diffusion is will be given by Ry is inversely proportional to this. It's given in the question. So Ry is inversely proportional to 1 by 8. Let's divide both of them. Rx upon Ry, dividing 1 and 2, you have Rx upon Ry is equal to 1 by 6 divided by 1 by 8. So this is 4 by 3 or 4:3. That makes option C to be the correct answer. Hope you understood. Next is question number 127. The masses of the carbon dioxide and water in gram respectively formed during complete combustion of 10 gram of glucose at STP are. Let's write down the masses of carbon dioxide and water in a complete combustion of 10 gram of glucose. So let's write the equation. This is C6H12O6 complete combustion. So oxygen, this gives you 6CO2 and 6H2O. This will be 6. This is your glucose, oxygen, carbon dioxide, and water. Now you're given 10 gram of glucose. How many moles are there? Moles of 10 gram of glucose will be equal to weight of the glucose divided by molecular mass of glucose. So weight is 10, molecular mass of glucose. This is 6 into 12 plus 12 into 1 plus 6 into 16. This gives me total of 180. So this is equal to 1 by 18 of moles. Moles of 10 grams of glucose is 1 by 18 of moles. So now from the above reaction, 1 mole from this reaction, 1 mole of glucose reduces 6 moles of carbon dioxide. So 1 by 18 moles of glucose will produce 1 by 18 into 6. That is equal to 1 by 3 moles of carbon dioxide. What will be the weight of carbon dioxide? That is equal to number of moles multiplied by molecular mass. So this is equal to 1 by 3 molecular mass for carbon dioxide is 12 into 1 plus 2 into 16. That is equal to 14.66 gram. So 14.66 gram. And what do you have to find out? Mass of the carbon dioxide and water. Okay, I have to go for water also. So mass of the carbon dioxide I've just told. This is 14.66 grams. That is present in option A and B. And let's find out the this same mass of water now. Similarly, 1 mole of glucose produces 6 moles of water, and 1 by 18 moles produces 6 by 18. That is 1 by 3 moles of water. So weight of water will be equal to number of moles multiplied its molecular mass. That is equal to 1 by 3 molecular mass of water, 1 into 2 plus 16. That is equal to 6 gram. Right. So for carbon dioxide and water, you have this as 14.66 gram, and this is equal to 6 grams. That makes option B to be the correct answer. Hope you understood that. Let's move to the next question, number 128. Enthalpy of formation of carbon monoxide, dioxide, carbon dioxide are this and this respectively. Enthalpy of combustion of carbon monoxide in kilojoules per mole is. Okay. Enthalpy of formation. First of all, let's do the reactions to formate carbon monoxide. This is when carbon reacts with half the molecule of oxygen, it gives you carbon monoxide. And the enthalpy change in this is minus 110 kilojoules per mole. Similarly, for carbon dioxide, this is the reaction. And let's say this is at delta HF dash. This is equal to minus 393 kilojoules per mole. To find the enthalpy of combustion to find the enthalpy of combustion of carbon monoxide, you have carbon monoxide plus half oxygen. This gives you carbon dioxide. So what is enthalpy change for this? This is given by delta HF dash minus delta HF, which is equal to minus 393 minus of minus 110, which is 393 plus 110, that is equal to minus 283 kilojoules per mole. That makes option A as the right answer. Hope you understood. Next is 129 question. At the temperature in Kelvin, when 1 mole of X and 1 mole of Y are heated in 1 liter of flask, 0.5 moles of Z is formed at the equilibrium. The Kc value for the reaction is, so you are given when 1 mole of X and 1 mole of Y are heated in a 1 liter of flask, 0.5 mole of Z is produced. Let's this. So if 0.5 moles of some Z is produced, that means there is some other element also that must be produced. This is 1 mole and this is 1 mole. This is 0.5 moles. Initially, okay, wait. Question number 129. At the temperature in Kelvin, 1 mole of X and 1 mole of Y are heated in 1 liter flask. 0.5 mole of Z is produced at the equilibrium. What is the equilibrium constant for this reaction? Let's do the reaction. X and Y react together to produce some Z, because this is 0.5 moles. That means some another element is also produces. Initially, at the time of reaction, you have 1 mole of X, 1 mole of Y, and 0 moles for Z and A. When the equilibrium is attained, because you are told that 0.5 Z is there, and definitely there is some another product which is having 0.5 moles, and this one will be reduced to this, right? So here I'm assuming that A is some product which is of the same size of Z. Now equilibrium constant is Kc given by concentration of Z into A. That means the products divided by the concentration of the reactants. This is equal to 0.5 into 0.5 divided by this, which is equal to 0.5 into 0.5 divided by 0.5 into 0.5, which is equal to 1. So the answer to the question, the equilibrium constant is 1. Option B is the correct answer. Hope you understood that. Next is 130 question. Identify the correct statements about the hydrides. In saline hydrides, oxidation state of hydrogen is +1. Wait. Okay. Yeah, you have to identify the correct statement about the hydrides. The first one says, in saline hydrides, oxidation state of hydrogen is +1. That is not right. The saline hydrides oxidation of hydrogen is -1. So this is incorrect. Next one, LaH is an example of interstitial hydride. This is true. Next one, NH3 and H2O, that is ammonia and water, have the tendency to form hydrogen bonds. This is also correct. They have the tendency to form the hydrogen bond. So the statement 3 is correct. Let's see over here. This is ammonia. So there is another molecule of ammonia like this. So this is tendency. There is a tendency to form this bond, hydrogen bond. And for water also, this is water. This is your and hydrogen bond over here. So this is also correct. Next one, the fourth one, electrolysis of molten sodium hydride liberates hydrogen gas at cathode. See, the electrolysis of molten sodium hydride liberates hydrogen gas at anode, not cathode. And sodium is formed at cathode. So this one is incorrect. That means the correct ones are 2 and 3. So you have D option as the right answer. Hope you understood that. Let's move to the next question. Here's a small correction in this question. This is supposed to be this hydrogen bond in water. It's supposed to be something like this. This, and there is some water molecule over here. So this is your hydrogen bond. Okay, hope you understood that. Next is question number 131. It says it's assertion and reason question. It says the first thing that alkali metals and their salt impart characteristic flame colors. Alkali metals and their salt impart colors to the flame because of their question number 131. Assertion says alkali metals and their salt impart characteristic flame colors. Reason is alkali metals have low ionization enthalpy value, so electron excitation is possible. So which is the correct, like this assertion and reason, which one are correct? Let's go for the assertion. Alkali metals and their salt impart characteristic flame colors because of their low ionization energies. Low ionization enthalpies. That means this assertion is correct. Alkali metals have the lowest ionization energy among the different groups in the periodic table. That means the reason is also correct and the assertion is also correct, which means you have first option as the correct answer. Hope you understood. Next is question number 132. When compared with alkaline earth metals, the alkali metals have greater hardness, higher boiling point, smaller ionic radii, lower ionization enthalpy. Alkali metals have low ionization energy as compared to alkaline earth metals due to their large size and valence shell electronic configuration. Alkali metals easily lose its electron to attain noble gas configuration, which is very stable. So you have the option as the correct answer. Hope you understood this. Next is question number 133. Kyanite and cryolite are the minerals of two elements, X and Z. What are X and Z respectively? See, kyanite is a mineral of boron, and what's the formula of it? Na2BO B4O6 OH2 3H2O, and cryolite is a mineral of aluminium with the formula of Na3AlF6. So you have option B as the right answer. Hope you understood this. Next is question number 134. Choose the correct statement from the following with respect to the inert pair effect. First one, it says Sn plus 4 is reducing agent, but Pb plus 4, lead plus 4 is an oxidizing agent. First of all, inert pair effect is less prominent in tin and than in lead. Therefore, plus 2 oxidation state of tin is less stable than the plus 4 oxidation state of lead. Hence, Sn plus 2 easily loses 2 electrons, easily loses 2 electrons to its plus 4 oxidation state. Hence, Sn plus 2 is an reducing agent. That makes the equation as Sn plus 2, Bn plus 4 after losing 2 electrons. And in lead, plus 2 oxidation state is more stable than plus 4 oxidation state. Why is that? Due to inert pair effect. Therefore, Pb plus 4 can easily gain 2 electrons to form Pb plus 2, acting as an oxidizing agent because it gains 2 electrons. That makes the first one. Let's go for the first one now that we read. Sn plus 4 is a reducing agent, but this is oxidizing. No, this is not correct because Sn plus 2 is a reducing agent, not Sn plus 4. Next, this is an oxidizing agent and this is a reducing agent. Wrong. This is also wrong. Sn plus 2 is reducing agent and this is oxidizing agent. This is absolutely correct. Last one, Sn plus 2 is an oxidizing and Pb plus 4 is a reducing agent. Wrong again. So, option C is the correct one. Hope you understood that. Let's move to the next question. Question number 135. In the following reaction, this C is an aromatic compound with the substituents D and E. What are these D and E? Let's see over here. What is this molecule? This is carbon, carbon, carbon. So here carbon. This is 2-methylhexane. 2-methylhexane. So when 2-methylhexane is passed over chromium oxide at 773 Kelvin to 100 to 20 atmospheric pressure, it gives you, let's write it over here, 2-methylhexane, which is this. 3, 4, 5, and 6. So when this one reacts in the presence of chromium oxide, 773 Kelvin, 10 to 20 atmospheric pressure, this benzene gives you this toluene over here like this. This is CH3. This is toluene and this is your A element. Now this A reacts with potassium permanganate and this hydroxyl ions, this is OH minus. By acidic hydrolysis, you have H2O ions as well. So let's write it over here. You have potassium permanganate, OH negative, and hydronium ions. Oh, this is hydronium ions, H3O positive. This undergoes acidic hydrolysis to give you benzoic acid, which is this. COH. And this is your B. This is your benzoic acid. Now, benzoic acid undergoes nitration in the presence of concentrated nitric and sulfuric acid to give you, let's write down. Now, this undergoes nitration in the presence of concentrated sulfuric acid and HNO3 to give you this. COOH and NO2 over here. This is metanitrobenzoic acid. And this is your C compound. Now you are asked that this C compound has a substituents D and E. What are those D and E? This D is COOH and E is NO2. That is COOH and NO2. Option C is the correct answer. Hope you understood. Next is question 136. The correct IUPAC name for the following given structure is 4 amino. Okay, these are the given ones. I'll just write down my own name. So let's zoom it a bit. Let's do the numbering for this functional group. You have this 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is the one. So you have at the third position, you have OH group, and at the sixth one, you are having NH2. Now, this IUPAC name becomes, let's frame the IUPAC name. You have at the sixth position, you have amino group 5, 2, 2, di. See, over here, you are having 5, 2, 2 dimethyl from this propyl non 4N 3-ol. So this is your D option. Hope you understood. Next is question number 137. An alkene X on ozonolysis gives propanol and ethanol. What is this X? So you have an alkene on ozonolysis. Alkene, which will be pent-2-ene. So let's go for the pent-2-ene. This is CH3, CH, CH, CH2, CH3. So this is 2-pentene or pent-2-ene. This undergoes ozonolysis. In the presence of zinc and water, it gives you ethanol. So CH3, CHO, and propanol, CH3, CHO, CH3, CH2, CHO. So these are the two ones. Alkene, like I'm taking pent-2 in on ozonolysis, gives you ethanol and propanol as products. See, you are having 2 carbon over here, 3 carbons over here. So X definitely is going to have 5 carbons, which makes it 2-pentene. That is option A. Hope you understood. Next is question 138. You have to match the following. So here is the first one. List 1 is the reaction, and these are the products formed. Let's start with the first reaction. You are having a benzene ring over here on reaction with chlorine in the presence of anhydrous aluminium chloride. It gives you chlorobenzene. This is chlorobenzene. So it matches with the fourth option. Next, benzene reacts with ethane chloride to give you in the presence of again anhydrous aluminium chloride. This gives you toluene. So this matches with the third one. B matches with the third one. Then is the C, which is this. Let's write down. You have C. It reacts with RCOCl. Again, anhydrous aluminum chloride. It gives you this product. Alkyl phenyl ketone. So the C1 matches with this one. Okay, it matches with the last option. And there is nothing over here, but to fulfill it, this one, let's say this is number 4. Let's say this is not number 4 because it has been already used. Let's say this is D. So D has this group, toluene, in the presence of potassium permanganate, potassium hydroxide, hydronium ions. This gives you benzoic acid. All right. So This is your, sorry, this is first, it matches with the first. So A matches with the fourth, B matches with the third, C 2, and D with the first one. This is right answer, option D. So this up D, it is, sorry. So this D, this is the reaction. Please note it down because it's not mentioned in the question over here. Hope you got that. Let's move to the next question. Question 139, a body-centered cubic lattice is made up of two different type of atoms, X and Y. Atom X occupies the body center and Y occupy the corner points. One of the corners is left unoccupied per unit cell. What will the imperial formula of it? Okay. See, as X atoms are located at the center and central atom contributes fully. Central atom contributes fully to the unit cell. Now, X atom occupies and Y occupies the corner points. Y atoms, they occupy the corner points. Okay, so okay, how many X atoms will be there? Because it is only, it is contributing fully in the center. In the center only one atom will be there, so X is equal to 1. Now Y atoms, they are at the corner points, and each corner point contributes, each corner point contributes 1 by 8. So if there are 8 corner points, but in the question, 1 corner point is unoccupied. So how many total corner points are used? Total used corner points are 7. So how much space is used? Or you can say total number of Y atoms used. This will be 7 out of 8. So this is 7 by 8. Now, what will the empirical formula? You are having X as 1 and Y 7 by 8. So it will be this. That will make X 8, Y 7. So this is the right empirical formula. X 8, Y 7. Option B is the correct answer. Hope you understood this. Next is question 140. X gram of urea molar mass. This is completely dissolved in Y gram of pure water and the solution is boiled at this temperature. If the boiling point of the pure water at this pressure is this much Kelvin, then what is the ratio of X is to, then X is to Y is, okay, you have to find out the ratio of X is to Y. You have to take Kb for water as this. Okay, first of all, elevation in boiling point. How much this is? Delta TB is equal to boiling point of solution minus boiling point of pure solvent. This is equal to 373.202 minus 373.15, which is equal to 0.052 Kelvin. Also, delta TB is equal to Kb into molarity, or this is equal to Kb into what is molarity? Number of moles of solute urea upon mass of solvent in kg. So 0.052 is equal to 0.5 52. It's given in the question. Multiply. Let's say number of moles as x and x upon 60. Number of moles x upon 60, because this is gram of urea and this is the molar mass of urea. Number of moles is equal to weight upon the molar mass, and the mass of solvent, it's y gram of pure water. So y gram of y gram of pure water. Question number 140, x gram of urea, molar mass this is completely dissolved in y gram of pure water, and the solution is boiled at this much temperature. If boiling point of pure water at 1.013 bar is this much, then what is the ratio of x and y? You are given Kb is equal to this. Okay, so how much boiling point is elevated? Elevation in boiling point is given by boiling point of solution minus solvent, pure solvent. So elevation, this is delta TB is equal to 373.202 K minus 373.15 K, or this is equal to 0.052 Kelvin. Now, delta TB is equal to Kb into molarity. So 0.052 is equal to Kb is given 0.52. Molarity is number of moles of solute, which is urea in this case. Number of moles of solute divided by mass of solvent. What are the number of moles of solute? Urea 0.052 is equal to 0.52 multiply. Number of moles is the weight upon the molar mass, which is 60. And weight of the solvent, it's in kgs. So this is, I'm converting that into the gram because okay, this is in gram. So I have to convert into kilograms. This will be y upon 1000. So this will cancel. This will be 0.01, or you will have here 0.1 is equal to x upon 60 into y multiply by 1000, or you will have 1 upon this multiply 60 upon this is equal to x upon y, or you have this as 3 by 5. So x raised to y is equal to 3 by 5, 3 is to 5. But I don't have those things. Rather, I'm having everything in the power of 10. So I have to rearrange it from here. I will resolve this thing. This will be equal to this 0 and 0 will cancel. So 60 into 10 power, 6 into 10 power minus 3 is x is to y. So that makes option A to be the right answer. Hope you understood that. Let's move to the next question. The conductivity of a solution of concentration 0.1 mole per liter of a weak monobasic acid HA is SCM minus 1. So you're given that molar conductivity of HA for infinity dilution is given by this, and the degree of dissociation of HA is this. All right. Question number 141, the conductivity of a solution of concentration 0.1 mole per liter of weak monobasic acid HA in Siemens per centimeter is. You are given that molar conductivity at infinity dilution for HA is this, and the degree of dissociation of HA is 0.02. You know the degree of dissociation is given by molar conductivity of the solution at the given molar conductivity of the solution at the given concentration at 0.1 mole per liter divided by molar conductivity at infinity dilution. So you have 0.02 is equal to lambda m upon this at infinity dilution. This is 400 given to you over here. So you have molar conductivity of the solution as 0.02 into 400, that is equal to 8 Siemens centimeter per molarity. And also molar conductivity for the given this molecule is equal to conductivity into 1000 divided by concentration of the solution. And this is 8 concentration of the solution. Let's see, this is equal to concentration of the solution. This is equal to 0.1. So 8 into 0.1 into 1 upon 1000. This is equal to Siemens per centimeter. So this is the answer to the question. The conductivity is option D. This is the right answer. Hope you understood. Next is question number 142. The rate of first order reaction doubles when the temperature changes from 300 to 300 Kelvin. The activation energy on the reaction in kilojoules per mole is which of these options? All right. So according to Arrhenius equation, log K1 upon K2 is minus EA upon 2.303, and this is multiplied by 1 minus T1, 1 upon T1 minus 1 upon T2. Given the rate of first order reaction will be double when the temperature changes. Question number 142, the rate of first order reaction doubles when the temperature changes from 300 to 310 Kelvin. The activation energy of the reaction in kilojoules per mole is, R is given to be this and log 2 is 0.3. According to Arrhenius equation, log K1 upon K2 is equal to minus EA point upon 2.303 multiply 1 upon T1 minus 1 upon T2. Given the rate of first order reaction, you are given that the rate of first order reaction doubles when the temperature changes from 300 to 310 Kelvin. That means 2K1 is equal to K2. The rate of the first order reaction doubles. That gives you 2K1 is equal to K2, which makes log K1 upon 2K1 is equal to EA upon 2.303. First is 300 and then you have the 310 degree, and you have log 1 by 2 is equal to EA upon 2.303. Here is R. I forgot to write R over here. And this will be 300 into 310. 310 minus 300, this will give you 10 only. And this is log 1 minus log 2 is equal to minus EA upon 2.303 into 300 into 31 into the value of R is given to 8.3. So you have EA as this is equal to log 1 is 0 and log 2 is 0.3, and this will be minus A. Let's write down minus 0.3 divided by multiplied by this 31 into 8.3. Minus minus will cancel, and I'm solving this whole thing. You will have EA is 6425.737 into 8.3, which on solving will give you 553.330 kilojoules per mole. So this is the answer, and B is the right answer, option B. Hope you understood that. Let's move to the next question then. Question 140, question number 143. The graph below is showing the relation between the extent of adsorption in X per m and the pressure offered at different temperatures. The correct order of temperature for the curves 1, 2, and 3 is. Let's write it down. Let's zoom it a bit. Question number 143. The graph below is showing the relation between the extent of adsorption and the pressure at different temperatures. The correct order of temperatures for 1, 2, and 3 curve is. Okay. See, adsorption is an exothermic process. Exothermic process. It decreases with increase in temperature. Adsorption decreases when the temperature is increased, and it varies inversely proportional to temperature, right? That is, this rate will be inversely proportional to the temperature. So according to the graph, X upon M is more for T4. Therefore, the correct order becomes T4, then T3, followed by T2. So that is, let's see, option B. So this is the right answer to the question. Hope you understood that. Next is question 144. A Lingam diagram is the plot of X versus Y. What are X and Y? See, as the Lingam diagram, it's a graph showing the temperature dependence on the stability of the compounds. Therefore, it's a plot between the standard. Question number 144, a Lingam diagram is the plot of X versus Y. What is this? X and Y. See, a Lingam diagram, it's a graph showing the temperature dependence of stability of compounds. It is a plot between, wait. It is a plot between the standard Gibbs energy, that is delta G naught, standard Gibbs energy, and the temperature T. Therefore, your X and Y are nothing but delta G naught and T. So you have first option as the correct answer. Hope you got that. Next is question number 145. You have to identify the correct orders from the following with respect to the property associated with. Okay, for the first one, you have to check out for the property associated with the bond angle, and you have to pick up the correct order from the following with respect to the property. Okay, first is the bond angle, and the given compounds are NH3, PH3, ASH3, and SBH3. As we move down the group, as we move down the group, radius of element increases, and with that electronegativity decreases. So bond angle also decreases. Therefore, NH3 is having the highest bond angle, followed by PH3, ASH3. This is having the bond angle of 107, 93, 92, and 91. So first one is the correct one. And you have to identify the correct orders from the following. Fine. So first one is the right one. The next one is NH3, PH3, ASH3, and SBH3 in terms of the basic character. See, the hydrides of nitrogen family contain one lone pair and on the central atom. As we move down the group, the size of the central atom increases. Thereby, their orbit becomes more diffused. Size of central atom increases, and orbital becomes less diffused. Hence, the nucleophilicity of the lone pair is less dense over the bigger atoms, thereby decreasing the basicity. Therefore, the correct order is NH3 followed by PH3, ASH3, and this. So that means this is also correct. Fine. The next one, PH3, ASH3, SBH3, and NH3 in terms of thermal stability. See, the correct order of thermal stability is, let's move with the C1. The correct order for the thermal stability is NH3 followed by PH3, then ASH3, then BH3. NH3 is the most stable hydride because the strong bond between nitrogen and hydrogen. The stability decreases as we move down the group in the periodic table. And this is the least, there's a least stable hydride because this is having a very weak bond between Sb and H ions. So this is wrong. Third one is wrong. The last one is SbH3. Question number 45. Identify the correct order for the following with respect to the property associated with. The very first property given to you is the bond angle, and this is the order which is given to you. See, as we move down the group, radius of elements increases, and therefore electronegativity decreases. Therefore, with that, bond angle also decreases. So you have first NH3 followed by PH3, ASH3, and then SPH3. This is right. Next, you have NH3, PH3, ASH3, and SB followed by the basic character. So look at the basic character of all these molecules. Fine. The hydrides of nitrogen family contain one lone pair. This is B. Hydrides of nitrogen family contain one lone pair on central atom. So as we move down the group, the size of the central atom increases, thereby the orbital becomes more diffused. Hence, the nucleophilicity of the lone pair is less dense over the bigger atoms, therefore decreasing the basicity. That makes this as the correct order. So this is also correct. Next, you have the thermal stability. See, this one seems to be incorrect because stability of the hydrides of the 15th group, stability of hydrides of 15th group decreases from NH3 to SBH3. This is because of their bond dissociation, enthalpy decreases because of their bond dissociation, enthalpy decreases due to increase in size of the central atom from nitrogen to tin. So the correct order is this, followed by PH3, followed by ASH3, followed by SBH3. So third one is wrong. Okay, let's go with the last, that is the boiling point. See, the boiling point depends on the molecular mass of the compound. As we go down the group, the molecular mass increases, and so does the boiling point increases. But there is an exception. In ammonia, there is presence of hydrogen bonding. And due to this, it's the bonds become more strong because extra bonds are involved and the boiling point becomes exceptionally high. Therefore, NH3 is having boiling point higher than PH3 and ASH3. Now, the boiling point of water is highest among all of these because it can form our 4 hydrogen bonds. In water, it can have 4 hydrogen bonds, which is the highest one. Okay. And if I look at the another ones, you are having SBH3 and you are having ammonia and SBH3 and ASH3 and PH3. The correct order over here is, this is having the highest boiling point, followed by ammonia, followed by arsenic hydride followed by pH3. This is having the least because there is no hydrogen bonding present over here and the weak covalent bonds are there, attraction forces are there. So the boiling point correct order is this. That makes this also to be the correct one. So you have A, B and D. These are correct, which makes option D to be the right answer. Hope you understood this. Next is question number 146. Which of the following is the strongest reducing agent out of all these? Out of all these, sulfur dioxide is the strongest reducing agent. In sulfur dioxide, I have +4 oxidation state, and it will attain +6 oxidation state. And wait. Sulfur dioxide, as sulfur is having +4 oxidation state, and it will attain +6 oxidation state and iron sulfate. That means it undergoes oxidation going from lower oxidation state to higher oxidation state. So sulfur dioxide will oxidize itself and reduces others and act as a reducing agent. While TeO, this and SO3, they act as oxidizing agents. That makes D to be the correct answer. Hope you understood. Next is question number 147. So this is the molecule and this is their shape. Let's do the matching. First is XeF4. Let's make it. You are having Xe, you are having 4 fluorine xenon, and you are having 4 fluorine atoms over here. To complete that, let's do this. So this is, now this shape is squared planar. So this matches with the third option. Next one, you have ClF3. This is Cl. Like this. This is bent T shape. So this matches. Next one is BRF5. So here is your bromine F, like this. And this. This is square pyramidal. And then you have IF7. So here is I, there is F, F, like this. This is pentagonal by pyramidal. So pentagonal bipyramidal, this is this and this is this. So your A matches with 3B, 4, C1 and D with 3. That makes, let's check D with 3. That is, that makes C option as the right answer. Because here this is, T is already taken by this, D matches with 2. Hope you got that. Next is question number 148. Which of the following compounds is having the maximum lone pair electron repulsions? Lone pair repulsion, that is LP, lone pair, LP repulsion is the repulsion between the various lone pair present in the molecule. More is the number of lone pair of the electrons in the molecule, greater will be the lone pair repulsion. So if I pick up the first one, that is ClF3. First one, ClF3, the central atom. Cl has 3 bond pairs. 3 bond pairs and 2 lone pairs. Therefore, okay, that's the second one. IF5. I has 5 bond pair. and one lone pair. Then you have SF4, S has 4-bond pair and one lone pair. Then is XeF2. It has 2 bond pairs and 3 lone pairs. So lone pairs are maximum in Xe. Wait, yeah, lone pairs are maximum over here because this is having 3 lone pairs. Therefore, the maximum lone pair load when repulsion will also occur in this. You have D option as the correct answer. Hope you understood. Next is another 49 question. Chromium 2 plus and manganese 3 plus do opposes for D4 electronic configuration. So, which of the following, which of the following is correct? First one, Mn3 plus is oxidizing agent where this is a reducing agent. See, if the element is behaving as a reducing agent, it means it undergoes oxidation. If the element behaves as an oxidizing agent, and then it means it is undergoing reduction. So for reducing, if it is behaving as an reducing agent, then the particular element is undergoing oxidation. And if it is behaving as oxidizing agent, then it is undergoing reduction. Now, chromium 2 plus has 3D4 D4 wait has 3D4 configuration. It will lose configuration. It will lose electron from 3D3 configuration, which is stable as it is half-filled T2G level. Therefore, this is reducing agent. Whereas Mn plus 3, this has 3D4 configuration and it will gain electron to form Mn plus 2, which is stable 3D5 configuration. Therefore, this is an oxidizing agent. So, this is correct. First one option itself is correct. And we have first option as the correct answer because this both are reducing agent. This is wrong, and this is also wrong. Hope you understood that. Next is question number 150. According to Werner's theory, the number of groups bonded to the central atom ion in coordination complex represent oxidation state, primary valency, secondary valency, or polyhedron. According to Werner's theory, secondary valency is represented by the number of groups bonded to the central atom or ion in a coordination complex. So this is the right answer. Right? According to Werner's theory, I'm repeating, secondary valency is represented by the number of groups bonded to the central atom ion in the coordination complex. Next is question number 151. The polymer sample contains 3 molecules of molar mass 10 power 3, 3 molecules of molar mass 500, and 4 molecules of molar mass 200. What is the weight average molecular mass? See, the weight average molecular mass is given by summation Ni. Wait. This is given by summation Ni Mi squared divided by summation Ni Mi. So let's go for that because I have all one polymer containing 3 molecules of molar mass 10 power 3, 3 molecules of molar mass 500, 4 molecules of molar mass 200. What is the weight average molecular mass? So weight average molecular mass is given by, this is equal to summation Ni square divided by summation Ni, which is equal to 3 into 10 power 3 whole square, 3 into 500 square, 4 into 200 square. Whole thing divided by 3, 10 into 10 power 3, 3 into 500, 4 into 200. So this is equal to 3 into 10 power 6, 75 into 10 power 4, and 16 into 10 power 4. Divided by this will be total of 5300. It was 3000, 1500, 800. This will give you a total of 5300. And on solving this whole thing, you will get your answer as 737.7. This will give you option B as the right answer. Hope you understood this. Next is question number 152. The heart projection shown below represents which of these options? Okay, the given heart projection is alpha D plus glucopyranose. So this is the one. It is having 6-membered pyranose ring having 5 carbon atoms and 1 oxygen atom. It is alpha because at C, 1 atom, you are having 1 hydroxyl group present downwards. So this is the right answer, option D. Hope you understood this. Next is 153 question. Which of the following will improve the latering property of the soap? Sodium stearate, sodium rosinate, sodium carbonate, or phosphate? Sodium rosinate. This is the filler which increases the latering property of the soap. Simple as that. Option B is the right answer. Next is question number 154. It says you have to choose the correct decreasing order of the reactivity of alkyl halides towards SN1 reaction. They are primary halide, secondary, and tertiary halide. So let's go for this. For SN1 reaction, carbocation intermediate is formed and the stability of the carbocation defines feasibility of the reaction. The order of stability will be tertiary, secondary, and primary. Therefore, order of reactivity of alkyl halide is tertiary halide, secondary halide, and primary halide. That is C option. Hope you understood this. Next is question 155. 1-propanol can be distinguished from 2-propanol by which test? This can be done by using Lucas test. This test is used to differentiate between primary and secondary and tertiary alcohols. By using Lucas reagent, that is anhydrous zinc chloride in concentrated HCl. This is Lucas reagent. Hence, 1-propanol, which is primary alcohol, can be distinguished from 2-propanol, which is secondary alcohol, by using Lucas test. So you have C as the right answer. Hope you understood. Next is 156 question. The product forms when chlorobenzaldehyde is heated with the concentrated sodium hydroxide is R. Let's write down the reaction when N-chlorobenzaldehyde reacts. This is the benzene ring and chlorine. This is M-chlorobenzaldehyde. This reacts in the presence of concentrated sodium heated in the presence of concentrated sodium hydroxide. It gives you M-chlorobenzoate. So this is chlorine, and here you have COONOA, M-chlorobenzoate. And one more thing, that is this. CH2, OH, and here is Cl. This is M chloro benzyl alcohol. So these are the two products which are formed. M-chloropenzaldehyde on reaction with the concentrated sodium hydroxide at room temperature gives you this sodium chlorobenzate, sodium over here, M-chlorobenzoate and M-chlorobenzyl alcohol. These are the two products formed. So that is this, sorry, option B. Hope you understood that. Let's move to the next question. Question number 157. It says the statement 1 says aldehyde on reaction with HCN gives cyanohydrin, and the statement 2 says cyanohydrin is a compound which consists of hydroxy and cyano groups on the same carbon. Let's do this reaction first. First of all, there is a aldehyde, CORH on reaction with HCN. What happens? This is CN negative and it gets attached to this carbon. So this will be CR, here is CNH and OH group over here. This is cyanohydrin. This is your aldehyde. Now, cyanohydrin reaction occurs when an aldehyde gets treated with HCN, forming a cyanohydrin product. Cyanohydrin is a compound which consists of the hydroxy group and the cyano group on the same carbon atom, right? So that means both of these things are correct, and the option B stands to be the correct answer. Hope you understood. Next is 158 question. In the given reaction, what is X? Okay, so over here, you are having your carboxylic acid, and here you are having amines. Okay, see, when alkyl nitriles are treated, alkyl nitriles on acidic hydrolysis gives you alkyl carboxylic acid. Let's make a alkyl nitrile. So you're having alkyl nitrile. Let's say this is your X on treatment with acidic. I'm undergoing this is acidic hydrolysis. This gives me alkyl carboxylic acid plus ammonia. This is number 1. So we are having the same group over here as this one. So X may be alkyl nitrile. Let's check for the second thing also. Now the same alkyl nitriles can be converted, alkyl nitriles can be converted to 1 degree amine by reaction with lithium aluminium hydride followed by hydrolysis. Just look over here. This reaction followed by the hydrolysis. Let's write down this reaction again. Now alkyl nitriles reaction with this and this, it gives you RCH2 NH2. This is your primary amine or 1 degree amine. So that means surely your X is nothing but alkyl nitrile. Okay, in the given reaction, what is X? It is nitrile. Option B is the right answer. Hope you understood that. Let's move to the next question. Question number 159. Which of the following reactions are used in the preparation of aliphatic primary amines? Number 1, Gabriel phthalimide reaction, Hoffman bromamide reaction, carbylamide reaction, or Sandmeyer reaction. The correct answer is these two options 1 and 2. Gabriel phthalimide reaction, it's a chemical process that converts chemical process that converts alkyl halides into primary amine in the presence of a strong base. Let's see this. So if you are having phthalimide, this is it. ring over here, and this again over here you're having N, and double O, this is H. In the presence of potassium hydroxide, this is your methylamide, and this gives you, here will be a benzene ring, followed by this will be C double O, and here you are having N, K, and here is C, O. Okay, so this on reaction, the presence of sodium hydroxide, it gives you this benzene ring. Here will be C, O, ONA, and here will be C, O, ONA. This is positive, negative, negative, and positive. And plus here will be RNH2. This is your Gribiel pethalamide reaction. And the second one, if I talk about the Hoffman-bromamide reaction, see, Hoffman-bromamide reaction, this is an organic reaction used to convert Hoffman-bromamide reaction. This is an organic reaction used to convert a primary amide to primary amine using halogen. Using halogen, base, water, and heat. So if you're having primary amide over here, RCNH2, this is primary amide. On halogen, sodium hydroxide, water, and heat, it gives you primary amine. So these are the two correct reactions, 1 and 2. So you have option B as the correct answer. Hope you understood this. Next is the last question for the chemistry, question number 160. In the presence of sequence of reaction, identify the major product B. So this is aniline. Let's write down the reaction over here. You are having an aniline over here. This is the ring and NH2, aniline. In the presence of CH3CO2O. This gives you, this is the benzene ring, NHCOCH3. This is acetylite. Now, this further reacts in the presence of bromine and acetic acid, CH3COOH, to give you there will be NHCOCH3 and a bromine group over here. This is P-bromo acetonilite. So this is your A, and the B is this. What you had to find out, the major product B is this option. Sorry, no, the bromo group is over here, not over here, not here. Let's check with the rest of the options also. I have option A as the correct answer. So students, with that, we have completed all the 40 questions of your chemistry sections, and hope you understood them well. Don't forget to visit our website, www.examsnet.com. Here you will find so many entrance exam question papers along with the detailed PDF solutions. You also must download our app. The link is available in the description box for a better preparation of your exams. A very best of luck for your exams. Keep shining, keep rising high. That's all for this paper. Bye.